Let's see an example of a percent change type problem that can be a little bit trickier. Let's suppose that we're told that a quantity goes from 88 to 77, and we want to find the percent change. All right, so in this problem, we know the starting value and the final value. Of course, there's always 100% here. And we want to know the percent change. We'd like to be able to set up a percent proportion to find this. We'd like to be able to write x over 100 is the change over the start. That's what we'd like to do. Unfortunately, we don't know what the change is, right? But we know how to find it, don't we? We can just do subtraction. The change is always the final minus the start. So in this case, it'll be 77 minus 88. Oh, that's going to be a negative number, won't it? So we'll rewrite this as addition, 77 plus negative 88. 88 is bigger, so the answer is going to be negative. The signs are opposite, so we want subtraction. 88 minus 77 is 11. Oh, now we're getting somewhere, right? We know that the change is negative 11, and now we know everything that needs to go into this percent proportion. Negative 11 over 88 is x over 100. Cross multiply. Negative 11 times 100 is 88 times x. Negative 1100 is 88 times x. X is negative 1100 divided by 88. So it's going to be negative divided by a positive is going to be negative. Let's do long division to find out what number. 88 goes into 1, no. Into 11, no. Into 110 once. Ten minus 8 is 2. 10 minus 8 is also 2. Bring down the 0. 88 goes into 220. 2 or 3 times. Let's try 3. 3 times 8 is 24. 24, 27. Okay, 3 was too much. Let's try 2. 16. 17. Well, it's got to be 2 because 3 was too much. 220 minus 176. 10 minus 6 is 4. Borrow again. 11 minus 7 is 4. I feel like answering as a decimal. Answering as a mixed number would also be fine. 88 goes into 440, I think, 5 times. 8 times 5 is 40. 8 times 5 is 40. It's almost like I knew that was going to happen. And that's why I chose to give a decimal. Negative 12.5. So let's see, how does that relate to my question? Find the percent change. I found it, right? So that negative 12.5, the percent change was a 12.5% decrease. So what made this problem a little bit trickier? And what made it not so tricky? The thing that made it not so tricky was that we already knew the starting amount. But what made it trickier was that we needed to subtract first. Right? So we were concerned with the final value, but we knew the starting value. There's another kind of problem where we know the starting value, but we're concerned with the final value, where we need to add or subtract at a different time. Let me show you an example like that first, before I have you try a problem. Suppose that a quantity starts at 30 and increases by 8%. We want to find the final value. So the starting amount is 30. The percent change is positive 8%. And the final value is what we want to know. Well, we can still set up a percent proportion using our 8% change. But that's not going to give us the final value, is it? No, it's going to give the amount of change. But if we know the starting amount and the change, of course we can figure out the final value. Right, so we'll say, we're going to call this x, right? X over the starting amount is 8%. Cross multiply, x times 100 is 8 times 30. 8 times 3 is 24. So 8 times 30 is 240. Thus, x is 240 divided by 100 is 2.40, but I'm leaving off the trailing 0. All right, decimal point goes here, 2 digits after. And now we use the fact that the final value is the starting value plus the change. So 30 plus 2.4, that's going to be 32.4, right? So the final value is 32.4. In general, in these problems, we're going to fill in the change row on the way to answering our question. All right, let me give you a problem of this kind to try. Suppose a quantity starts at 20 and decreases by 5.5%. What is the final value? Remember to organize your information into a table, and that since you know the starting value, your process for solving this problem will probably involve filling in the change row. Pause the video and try this now. All right, so start, change, and final. We're interested in amount and in percent of start. The starting amount is 20, which is of course 100% of itself. About the change, we know that we have a negative 5.5% decrease. And the final amount is what we're looking for. So our strategy is going to be to fill in the change row. We're going to call the amount of change x. And then we can set up a percent proportion to find that. So we'll have x over 20, right? The starting amount is always the base, is negative 5.5 out of 100. Now what? We cross multiply. X times 100 is negative 5.5 times 20. The answer is going to be negative. Let's work that out. 5.5, 20 times, 2 times 5 is 10. 2 times this 5 is also 10, plus 1 is 11. Bring in the trailing 0, and then I want 1 digit after the decimal point. So my answer is negative 110. Thus my x is going to be negative 110 divided by 100. So negative 110, 2 digits after the decimal point, negative 1.1. Is this the answer to my question? Oh no, that's the value of x, right? My final value is going to be my starting value plus my change. All right, opposite signs. So 20 is bigger, so the answer is going to be positive. But opposite signs, so I want to subtract. Right? 20.1.1 minus fill in a 0 here. Gotta borrow 1, 10, borrow from the 10 makes 9, 10 left here. 10 minus 1 is 9, 9 minus 1 is 8, 1 minus nothing is 1, so positive 18.9. That's the final value, is 18.9.